Okay. Yes, I used to script Valerie to get transcripts for things that we do, because a lot of times, so there's two things I use, and the world, I guess, can hear this, to because Valerie asked about this, is one second here. One is to script, which I can take any video and it'll give me a transcript of. So that way we can put that into YouTube and other places where if you put a transcript of it, it boosts your ability on it. The other thing is there's something called Fathom. And Fathom, basically it records and makes a transcript and summarizes what your discussion is live. And I use that if I'm having a first meeting with someone typically, because I want to go back and remember what I kind of said. Yeah. But now we're live to the world out there. It's me, Thomas Hall, Executive Director of Clean Start, with Mark Berman here. And I'm going to start by sharing my screen. All right. Welcome to our Clean Start perspective today. It's been a while since we've had one of these, so please be patient if we dust off any cobwebs here. But first, I'd like to recognize our sponsors: SMUD, Blue Tech Valley, River City Bank, and the CMC. And I really want to highlight Blue Tech Valley because right now we're opening up an accelerator called the CEO Crash Course for executives of early stage companies that want to figure out, how do I bring my product to market? How do I make sure I have a customer? It's an intense course, 16 2.5-hour classes over 8 weeks. So go to cleanstart.org and sign up for it. You can also email me at thomas@cleanstart.org and I can make sure to sign you up with it. I'd also like to thank our other supporters out there, Mike Bell, Gray Rock, and regular Patreon donors. You mean a lot to us. You help us put these on, and we're grateful for it. Now, I'd like to invite my guest here, Mark Berman, founder of NightBreeze. Mark is not a new face to the clean tech community. He's been doing work on buildings for a long time, research, innovative products. So today I'm going to ask him a lot of questions about, what he's kind of done and where he sees things going, along with curiosity about where he's been taking NightBreeze, his company. So I'm going to stop sharing and let Mark take over.
All right. Well, thank you, Thomas. I appreciate the opportunity to be here. So just a little bit about myself. I've been in the energy business or energy industry my entire career. And I started out on the oil and gas side of that in Texas, and first with Exxon, and then moved to West Texas, eventually had a small exploration and production company with a partner. And when the price of oil collapsed in the 80s, that was a negative at the time, or it certainly felt like it, but it became my opportunity to retool myself and come to California, which I'd always wanted to be. And I did, and over time got into the energy efficiency business. And that industry was a better suit for me. It felt more comfortable, and even back in the 90s, people were indicating the problems with the oil and gas business. And anyway, been in energy efficiency pretty much ever since, with a focus on residential and small commercial, and spent 18 years with Davis Energy Group, starting as a manager and then principal and finally president the last couple of years. And we sold that to Gas Technology Institute, and that was I think that worked out well. They, however, did not want product. And one of the products that we had been developing with support from California Energy Commission and a little bit from the Department of Energy was NightBreeze. So since they didn't want it, I took it, and I've been refining it ever since with some significant changes to it versus the first iteration. And that's been my business focus. So at this point, I think the best thing to do would probably be to share my screen and show you some slides. Pictures worth 1,000 words. And I think at that point, folks will have a much better idea of what I'm talking about. Okay. So in essence, what I'm talking about is smart, fresh air for homes. And right now, the way we ventilate is static. And by that, I mean, it's a constant ventilation rate, in many cases 24/7 through a energy recovery ventilator. Smart fresh air is smarter than that. It looks at the question of, do we really want to bring in 105-degree air at 3 o'clock in the afternoon for ventilation when that's going to need to be conditioned? And yes, it goes through an ERV, and that brings it from 105 to, I don't know, 90. I'm not sure exactly what the equation is, depends upon the ERV. But the point is, even then, it's an energy penalty. So smart fresh air looks at things like that and tries to provide fresh air in a smarter way. And, you know, we've been doing this for a long time for commercial buildings. A lot of commercial buildings do, sometimes it's called a night flush, from like 4 to 6 in the morning to pre-cool the building in the cooling season and get a head start on air conditioning. And that lowers the load, saves a lot of energy, and freshens the building. Dedicated outdoor air systems to maintain ventilation, especially when you talk about say a big box store like Target or Walmart. They have a lot of people coming in and out. They need fresh air. And in office buildings or campus buildings, we may have demand response. And for example, when a bunch of people go into an auditorium for a lecture or a meeting, or meeting room for a conference, the CO2 level goes up, the sensors recognize that, and the ventilation starts. And that's all about indoor air quality. So we've been doing things pretty intelligently in many commercial buildings for many years, but not so much on the residential side. On the residential side, there are some industry trends that are worth looking at. For example, indoor air quality monitors, like the one over here in Element that I have, they're pretty effective. They are, the sensors are more accurate than they've been in the past. They're less costly, and they let you know not only if you have an air quality problem, but pardon me, what that air quality problem might be. Is it CO2? Is it volatile organic compounds? Or is it something else? So, pardon me. The point is, most of these systems, just about all of them, are letting you know there's a problem, but they aren't doing anything to solve the problem. Now, Broan-Newtone makes a lot of ventilation systems, ERVs, heat recovery ventilators, bath fans, lots of bath fans, other exhaust fans, fly fans, kitchen hoods. And they have a system that does look at sensors for air quality. And if they note that CO2 or particulates, PM2.5, whatever, are beyond the limit, they'll turn on one of the Broan systems. For example, the bath fan. But typically that's low flow. So that improves air quality, but we're not taking advantage of cool nights to pre-cool a building. And that's where the energy efficiency and the savings comes in. Ecobee introduced a smart thermostat last year that also monitors CO2 and volatile organic compounds. And it sends a message, for example, an email, if something gets out of whack. So if two people are sleeping in a bedroom with the doors and windows closed in a relatively tight house, CO2 levels can get well beyond what's considered healthy, say 3, 4 in the morning, And this thermostat would recognize that. But what happens? It doesn't do anything about it. The next morning you wake up to an email saying, oh, you should have opened your windows at 3 in the morning. Well, that's not solving the problem. So I think the next step is what I like to call smart fresh air. Let's take these more sophisticated and less expensive sensors for indoor air quality and outdoor and indoor temperature and relative humidity sensors. And let's combine those with the functionality of a ventilation fan. And this can be in combination with an energy recovery ventilator or not. But let's respond to these IAQ events. And when conditions are right, let's do some pre-cooling. So in almost all of California, in almost all of the West, in the upper tier states, there are many days when it's warm during the day, if not outright hot, with a high of say 95 or 100, and it cools off at night. Big diurnal swing, might cool off to 60 degrees at night. Well, once the outdoor air temperature is 5 degrees less than the indoor air temperature, and as long as the humidity is not too high, which it typically isn't in the West, why not do some pre-cooling? But let's do it with an ample volume of air, like 1,000 cubic feet a minute, whereas an ERV typically is about 100 cubic feet a minute. With 1,000 cubic feet a minute, over time, you can really make a dent in the heat of the house. So it's kind of like a whole house fan, if you're familiar with those, which is a sizable exhaust fan, even 2,000-3,000 cubic feet a minute, but you have to open the windows for those. You have to operate it manually. It's not smart. Well, when the windows are open, you're getting dust and allergens and noise, and some people just don't want to do that. They have somebody with asthma in the household or whatnot. So with this system, the windows stay closed and the air that's coming in is filtered. So we capture the dust, the allergens, or at least a lot. Conceptually, if here's the ducting system for heating and perhaps air conditioning, NightBreeze, in this case, in a housing, has a duct to outside air. That's the outside air supply duct, which might go to a chimney vent or a gable vent, louver, whatever. And it's really pretty simple. We've got a filter, we've got our own blower and motor, and we've got the controls where the smarts are. And when conditions are right, we're supplying air into the ducts, and it goes to every room that's connected to the duct system. Excuse me while I grab a drink here. Getting all choked up about all the energy we're going to save here. So this is one rendition of it. Here's another. Let's say we've got an existing furnace here and the plenum that leads to the supply ducts. And here might be an outside wall. And so here's our outside air louver. And the outside air can flow through that. And it's powered by a fan. And we've got backdraft dampers, etc. I won't go into the nitty-gritty details, controls. But the point is, it flows into this plenum, which then goes into the ducting. And another objective of Smart Fresh Air is to make a system that can be retrofit on a significant portion of existing houses. The original version of NightBreeze was really designed for new construction and made it difficult, challenging, and expensive to retrofit. So we've made some changes here to avoid that. And why don't we control this with an app? Instead of using a separate thermostat that SmartVent does, which is a precursor to all this by Butler, now Valero. Instead of using a thermostat, which also NightBreeze originally used. Let's use an app. And let's keep it simple. Once people set the parameters, people have enough to think about without thinking about fresh air and turning on a system, turning it off. Hopefully it's set it and forget it. And if you're wondering, oh, is the system on? Well, you take a look at the app. Yeah, NightBreeze is cooling the house. 76 inside, 61 outside, and we're taking advantage of that. And at times, if there's a mishap and a lot of smoke in the kitchen, for example, you might say, okay, let's turn this on for 60 minutes or whatever. And so there's manual control, but that's the exception. The forget it part is hopefully the rule. So what was changed and what became part of the patent that I was able to get for the upgrades and changes to the original NightBreeze system? Well, first of all, we're now connecting to the ductwork, and we're doing it in a way that makes it easier to retrofit. And we're tying into all the rooms of the house that are connected to the furnace system and the duct. So we're integrated with the central HVAC system. We have an independent blower. So we're not trying to tie into the furnace blower, which sounds from an engineering view more efficient. Gee, there's already a blower there. Do I need a second blower? Well, blowers have become very sophisticated. The controls for them are sophisticated. The protocol varies by manufacturer and even by model sometimes. And we would have to have so many different models of this to tie into existing furnace blowers that it just wouldn't be practical. And ventilation fans have become less costly and more sophisticated. And I might say that a lot of the reason is when you grow cannabis in a greenhouse, you need a lot of ventilation. You've got workers in there. You don't want them hearing a lot of noise. So some ventilation fan manufacturers have picked up on that. And now we have much more sophisticated, efficient fans that are available. So I think, whatever your opinion might be, the cannabis industry needs a shout out for pushing along the ventilation industry. So we certainly appreciate that. We also have a lockout so that when the furnace fan is operating, say the air conditioner turns on, we don't want to be competing with that. And the furnace fan manufacturers don't want us competing with that. So when that fan is detected to be on, our system shuts down. The air conditioner is primary. Then we have the pre-cooling functionality, which saves energy and saves carbon while we're enhancing the health and air quality. And that's in the patent as well. Optionally, and I think this would probably be the base case after some discussions with various HVAC installers, who are, by the way, key. If the installers don't like your product, you can kiss it goodbye. They'll badmouth it, and it just won't sell. So a single housing should make it easier, and that's covered by the patent, as well as maximizing ventilation when outdoor air is moderate. We may not be able to ventilate completely when it's cooler outside than in summertime or during the warmest part of the day in the wintertime, but at least we can avoid the coldest day in winter and quit bringing in 28-degree air, or depending upon where you are, 15-degree air. And in the summer, the inverse. So what this is for, and what I am looking to partner with, is a ventilation innovator that's got the capacity to prototype and bring this forward and commercialize it. And in fact, that would be the next step. License the patent, create some prototypes, and the firmware is started but not finished. Some demo units and a pre-launch would be the next step. my objective, as you can tell by the gray hair, I'm at the latter part of my career, not the earlier part. And, I'm not looking to head up a startup to turn this into a huge product. And in fact, I think it's a product more than it is a company. So I'm not sure that by itself it warrants that. So I'm looking to turn the project over to a team with the right expertise to commercialize smart fresh air, and of course share the upside and be involved to the extent it makes sense. I'm not just gonna, say goodbye to the baby. And this goes back to me again a little bit, and you already covered that. And that is my story, and I'm sticking to it. Smart fresh air.
Love that page, Smart Fresh Air. I was trying not to laugh at the whole Ecobee sending an email to someone that might be having carbon monoxide poisoning.
Yeah.
You're like, okay, that's nice, but it's like, yeah. Some kind of questions on this, like, what do you have an idea of like the price point you're trying to target for the
I
NightBreeze?
think we're looking at an installed cost of $3,000 to $4,000, something of that nature.
Okay.
It depends upon, if it's installed when there's a furnace change out going on at the same time, the increment would go down.
Yeah. Then on kind of the same thing, do you have a kind of an idea of what the savings someone might experience with it if they're able to reduce their energy cost?
That's a great question. Thank you. So the earlier incarnations of this, before the advancements were made, basically perform the same function. And thanks to Department of Energy and the Energy Commission, we were able to get some prototype units out there, and some field studies were done by Davis Energy Group, but also by others. PG&E hired a company called, I think it was Matrix. And the bottom line is, depending upon climate, cooling savings can be as much as 50%. It can cut cooling costs in half. In my house, I think that's about the case. Now, in other areas like on the coast where people are saying, gee, I put in air conditioning, it's only, uncomfortable 10 or 15 days a year. Well, if we can cut that 10 or 15 days a year down to 7 or 8 days a year, then we might be able to eliminate air conditioning completely. Now, there'll still be an energy cost for running these blowers, but thanks to the cannabis industry and others, they're very efficient and it's not a big cost.
Mm-hmm. Yeah. A little backstory for me, like when I was growing up, it was my job at 2 or 3 a.m. to get up, open a whole bunch of windows in the house, and then turn on the attic fan to cool the house. And I had to do that every day of the week. So from a value standpoint, I'm like, this resonates with me.
Great.
As someone who was once a teenager that hated getting up at 3 a.m. to open the windows for the house and turn on the fan.
Yeah, that's very efficient. Can I guess that your dad was or is an engineer?
He is an engineer. He's now retired, focusing on electric vehicles out there. So if you're ever in Sacramento testing out electric vehicles, you probably will run across him.
Right.
But one of my kind of questions on it, and I saw this kind of in the chat, someone asked, what about outdoor air quality? How does it address that? So yesterday we had smoke in Sacramento, not like we have had in the past. But where we know there's going to be future days where the outdoor air quality is bad. And I think even when it's a fire, it's bad at night, right?
Yep. So the short answer to that one is, when the air outside is really bad, smoky, particulate, don't ventilate. We can put in a high efficiency or a high MERV, filter, etc. But there comes a point where the best thing to do is just close the windows and shut off the ventilation. And so how do we monitor that? Well, the internet really provides a lot of information, including, we talked earlier about having an outdoor air temperature sensor. The information available on the internet as far as temperature is so granular, you may not even need an outdoor air temperature sensor. And you probably don't need an outdoor air quality sensor because that information is available too. So we do connect with the internet. And if the outdoor air quality is poor, we don't ventilate.
Yeah. Yeah, I think that answered the question. The other one I had is you had mentioned about, you're going the process of getting these installed, like for a large building, it's, it's an economic perspective that they're always kind of looking at of how to make their building better and able to seek a return on it.
Right.
At the home level, there's also one of the obstacles you mentioned was HVAC installers. And I know just from experience of talking to a whole bunch of, different startups that the gatekeepers on this, and one of the most important kind of customers you have to have is all these small local companies doing the installs. Because if they don't want to sell it, they end up being, it doesn't happen. So I was wondering, what type of conversations have you had with installers, HVAC people, or have you tried to, I guess, understand, their perspective on this?
Yes. Yeah, that's really important. And I've talked with a couple of folks that have been in attics and garages and basements installing, and also own HVAC installation companies. And when I showed them the two versions, one in a box and one not, they both said, put it in a box and make sure that box can get into the attic, and make sure that that box can fit comfortably between studs, joists, whatever may be up there. So I have some dimensional parameters, and also I've thought about, well, earlier I was looking at larger fans with larger cubic feet per minute, but they're heavier, they're bigger, and you can accomplish a lot once you get in the area of about 1,000 CFM. So that's another parameter that I've looked at to make sure you can easily get the device where it needs to be, whether it's the attic, the basement, or the garage, and get it installed.
Yeah. So kind of, when I first talked with you about this, first thing I did went in and looked at my my heater and air conditioning unit, or heater in the attic, and then also my unit that's kind of in. Nothing in my house is really conveniently placed. But how small of a space can you fit this into?
Well, it's probably not going to want it more than about 1.5 feet wide. It may be, I'm spitballing here a little bit.
Yeah.
The engineering hasn't been done. It may be 30 inches long, and then 1.5 feet by 1.5 feet. So 18 by 18 by 30 might, somewhere in that range. Also make sure
around it, or
it's possible it could be hung in a trapeze sort of way, depending. You want to look at weight, but there are some attic fans, whole house fans that are mounted that way now, so that might be a possibility. If there's a platform available, of course, that's easier.
Yeah. You also mentioned kind of needing, I guess, HVAC or like duct and a kind of innovations to, I'm assuming, kind of figure out the best way to get it into like a retrofit and make it fit in there. What are some of the obstacles you've seen that you're hoping to overcome with some of this innovation?
Well, and especially in the beginning, it's not one size fits all. And one of the things we need to do is develop some a series of questions that can be asked quickly to ascertain whether or not a particular home is a good candidate.
Mm-hmm.
And unfortunately, there will be a number, a lot of houses. Oh, you live in a 100-year-old house and you've got mini splits and no ducting. Well, sorry, this is not the system that's going to be helpful. Or the air conditioner and the furnace is in the closet. It's very tight. There's no access, or there's no room, basically. Again, it may not be applicable, but there are so many situations that are applicable. By the way, I saw a question come up from Valerie. That's a real good one. We're pressurizing the house. We're pushing, say, 1,000 CFM of air into the house. Where's the exhaust air go? The simplest answer is if a window or two are opened, not much, maybe an inch or two, and locked in place for security, that would be the cheapest way to handle the exhaust air. And they could either be, I think permanently left in that condition. Another way would be to have a barometric kind of a flapper damper that goes through an outdoor wall, so that when the pressure in the house goes up by enough, the flapper opens up and the air releases. And it can get more sophisticated and therefore more expensive from there. But those are the simplest responses and the least costly.
Okay. Well, good answer on that. So then also you mentioned kind of having, I guess, your own sort of app for it, but I know it seems like there are a lot of the sensors out there, a lot of the home equipment out there. They all have kind of different interfaces.
Yeah.
Are you trying to make it so that it, that yours is standalone or that it connects in with them? Because I'd imagine you wouldn't want something where inadvertently you're opening up, pumping outside air in and trying to heat your house or something at the same time.
Right. Well, the way we avoid that is if you're going to heat or air condition the house or even recirculate the air, the furnace blower is going to be on.
Mm-hmm.
And it's not too difficult to detect that. There's a wire from the thermostat. I think it's the G wire. And if that's energized, the fan is on. There's other ways to detect that. So if that blower is on, we stand down. We just don't operate. So we avoid overloading the ducting. What was the other question?
I think that was mostly it. Oh, integrating with other apps or other software
right.
hardware beyond just the
a lot of people are looking at their phone. They can't find the app that they really need because there's too many apps on the phone. So do we really need another app? Okay, got that. I already have one that operates my Linux system. Well, if we did some kind of a deal with Linux, then yeah, it should be easily integrated. And actually, as the app is built, and I'm not a computer programmer, I learned Fortran years ago, but I know what a subroutine is or a subassembly. If we can create this thing in so that a Linux, a train, a carrier comes along and says, I think we like this. We'll offer it, and we want to integrate it with our app. Hopefully, it's kind of pick and choose which subroutines fit, but that's to be determined.
Excuse me. Okay. Another question that I had, I think I'd asked you this before, is, I was looking at, the design on it. What about replacing the filter? When I looked at the thing, am I going to have to go into my attic and replace a filter? Is this, it's already frustrating to replace my house filters right now.
Right. That's probably, to tell you the honest truth, our most sensitive point. Because that filter needs to be replaced about every 3 or 4 months. It's going to load up with the dust and whatnot in the outside air. If the outside air is coming through a louver in the side of the house, then frankly, what I'm thinking is make that filter accessible from outside.
Mhm.
So yeah, you're going to need a step ladder, but that shouldn't be too difficult.
Mhm.
Otherwise, if the attic is accessible, or if the unit's in the garage, which is certainly accessible, then yeah, got to get to it and be sure that that's doable.
Mhm.
It's a different filter than the furnace filter, which also needs to be changed. So
Mhm.
yeah.
Yeah, this reminds me that I have to change all my filters right now. So, um, so on you've had, I know it's been tested in the real world in some extenses, and you've made changes to it since then, right?
Right,
You've updated, improved it,
right.
made some iterations on it. And it sounds like you're looking for kind of a larger group to, partner with to kind of bring it to the market. Maybe one that has
Right.
more kind of experience in it. If you're comfortable, do you mind sharing what your experience has been and trying to connect with larger groups? Because I know a
Oh,
lot of
sure.
entrepreneurs out there are like, okay, how in the world do I do that?
Yeah. Yeah. Okay. So one of the things that's been helpful, I bumped into something called the Corporate Accelerator Forum, which is based in Silicon Valley. And they've been working with large companies for many years, helping them partner with entrepreneurial companies to bring in new technology. And
Mhm.
it doesn't matter, this is all over the map. High tech, of course, communications, software, but also pharma and other more traditional industries. So I joined that group when they expanded to starting to work with entrepreneurial companies. And so I've learned a lot from that, from joining that group. That's one thing. I've reached out over time to the more obvious players in the business that make, like Panasonic and Broan and that make energy recovery ventilators, supply fans, etc. And you know, it's it's not been the most uplifting experience in the world.
Mhm.
Uh, a lot of people that are interested, I think they're curious. Go through a slide set like we just did, and we'll get back to you, and then they fall off the face of the earth.
Yeah.
So some have indicated a little more interest than others, but the industry is pretty conservative. So that's not yet, I'm not done doing that, but that's not yet produced the right partnership. I've talked as well with a company that brought another product to market. It's a small company. They got an SBIR grant to develop and demonstrate this low-cost energy recovery ventilator. And the way that stands is, let's go find a grant offering that fits. And I'm looking for that, and that alone is a bit daunting. And what some of the links that you have put out have been really helpful, but still working on that. But if we find the right grant opportunity, then that would be another way to coalesce with this group, create some new prototypes and test it.
Okay. We got a question from Valerie asking if you're attending CDIA next week, which I'm not familiar with what that is. Yeah.
And neither am I. So as of the moment, I'm not, but sounds interesting.
Valerie, do you want to share what that is? Okay, well, we'll look that up It looks like it's
Actually, I
not
just
smart.
thought it'd be easier to go off mute rather than type it in.
Yeah.
Hi, we're Valerie and Mark. We have a smart home technology YouTube channel that's at my. Anyway, so the CEDIA show, it's a show for custom integrators who do like home theater and high-end smart home technology.
Oh, lighting and
Lighting
so
and
forth.
that kind of stuff. And some, you know, obviously there's always a smart home tech there. So this kind of stuff, air quality and water monitoring, and there's always vendors like that at that kind of show. But those
Yeah.
are people who do, you know, high-end home installation of products. So those might be people you're interested in meeting, or maybe like the builder show in Las Vegas. We haven't been to that one. We go to CES every year in Las
Right.
Vegas, which is, you know, that's obviously a great place to meet people, but it's huge. So it's not quite as targeted.
Yeah, and I've also gone to the air conditioning and heating conference, AHR, which is usually in parallel with ASHRAE. And you know, what I'm looking for right now is a group that's got manufacturing capability. Although input from installers is great, but once we've got at least to the prototype stage, then it'll make sense to interact with high-end installers. That's certainly a great way to start.
And there's always, you know, it's a technology community too, right? So we've seen over the years, like I think you mentioned Swidget in your presentation.
Yeah.
Swidget started by going to CES downstairs in Eureka Park, where all the startups are, and now I think they're exhibiting at the CEDIA conference. So
Where is it?
it's in Denver.
Uh-huh.
It's probably not, you know, immediately appropriate, but you never know who you might run into there, because everybody's looking for ideas how to increase business and how to bring more value to their customers, right? And air quality is obviously a growing area there.
Yeah. You know, the thing about air quality is you just don't know when it's not good. I mean, if a house is really stuffy, okay, you know it. But you could be in a situation where particulates are really higher than you want them to be, but not outrageous. Same for CO2 or VOCs. And you just don't know it. You might get a little bit of a headache or whatnot. So putting these sensors in and marrying them with an ability to do something about it, it's an intangible. And it's a little difficult to explain. It's not like, you know, if you're looking at water, somebody else came up with this analogy. And if somebody said, you know, here, why don't you have a glass of water? And you look at it and it's brown, it's got little stuff floating in it, or it's cloudy, kind of grayish. You go, oh, you know, I think I'll pass. Thanks a lot. I'll go buy a Coca-Cola. Not so with air. You just, you know, it could be like that, but you don't know it. So it's an interesting phenomena, but it's a real problem. Schools, it's really clear in schools. You know, this is off topic a little bit, but you put 25, 30 humans, even small ones, in a classroom and don't adequately ventilate, and Sally and Johnny are going to, you know, take naps and after a little while.
Yeah,
whether they want to or not.
I really resonated with your slides where you talk about, you know, there's all these monitors, because we've done a lot of testing of both air purifiers and air monitors. And we have one system where we've got quality monitors that work with the air purifiers, but we don't notice the difference really. And I just started doing a review of a new sensor that gives us all this information. And again, it's doing this thing where it sends a notification. It says, oh, the TVOC levels are going up. You might want to open your window. And usually when I get that, I'm not home or, you know, it's not convenient, or, you know, I just think, well, how stupid, it's 100 degrees out. I'm not going to open the window.
Right.
So it's notifications, extra information, but there's nothing to do with it.
Like, and some of these notifications honestly drive me insane. The amount of companies that are trying to advertise at me through push notifications.
Right.
Like, you have one that's like health and risk. And then there's like, all these other ones that I'm constantly like block, ignore, block, ignore, block, ignore, but then
Yeah.
they still come up. And like my Alexa is supposed to tell me air quality things, but most of the time what it tells me is like, do I want to reorder Red Bull? And I'm like, like, what about all the stuff that you're
You wouldn't
supposed to
care?
be doing? And it's like, well, you had a notification, but you said you didn't want like third-party notifications. So we didn't tell you about air quality.
Yeah, I think, notifications are a problem. I mean, for us, we get so many crazy notifications from all the stuff we test. And I think the whole thing that you have in your system where you kind of like set it and forget it, I think you have to do that. Systems have to run without you being involved. They have to run like people always ask, well, what happens in the smart home if my app ends, can I turn my lights on and off? And I said, well, there's always a mechanical switch to it. And I think you have to think in those terms. Hey, by the way, just so you know, like Brown Newtone is going to be at CEDIA next week. So there are definitely people in there that are in your space.
Hmm.
When I look at the whole thing, I mean, it makes a lot of sense when you start thinking about the integration of stuff. And definitely you've got some issues you've got to deal with. I don't think your pressure solution is going to work, at least on a formal basis.
It's not ideal. I think
it's like
what's preferable is the damper, the pressure.
But if you looked at kind of a step is if you looked at like a room, like kind of like a room air conditioner, if you looked at like a room fan that does the same kind of thing, right, and all automated and everything else, but at least in the house, and then let the regular system take care of the moving the air around the house.
Well, it's interesting you say that. There's another company called EcoBreeze, ECO Breeze.
Mm-hmm.
And they've developed a room by room system. It's a window system. And we're kind of like brothers in arms. And in fact, that company is run by two brothers, one in Tennessee and one in Tucson. So we have been marching down this path in parallel and communicating and trying to help each other where we can. And they've been running into the same issues. They're also looking to find the right manufacturer to take on the product. The EcoBreeze 2, they were selling it through Amazon. It still may be available. And they're looking to commercialize in a bigger way. That does exist room by room. And there are situations where that makes more sense. And I think their sales point has been around $250 or so. So it's certainly economical. And if somebody is, for example, renting a 2-bedroom apartment and they particularly want to do something about their bedroom, but they don't want to exactly enhance or upgrade the apartment for the landlord because they're not going to be there forever. This is an ideal situation. And they've sold quite a few of them in New York City. You wouldn't think that that's the place where it would be popular, but it is. A lot of apartments and exactly the situation I said. So yeah, good thinking. That product does exist.
Oh, that's cool.
$260 gets one on Amazon.
Yeah.
Yeah. And we're going to kind of get into wrapping it up now. I do want to also highlight, have you checked out Cal Testbed and Cal Next?
Yeah.
Cal Testbed's going to be reopening again. I think you might be a bit beyond that because that's more about testing at UCs and colleges around and they provide vouchers for it. And they also provide people that figure out, how to do appropriate test to bring you to commercialize your product. And then Cal Next Ideas and Projects, they focused heavily on HVAC systems and buildings.
Okay. So if I just Google CALNEXT.
I'll just toss it in the chat there. And if you can always, you have my contact information, so you can always.
Oh, there it is.
There.
That's easy. Yep.
Yeah.
Well, that's the beauty. There's a lot of things that are beautiful about coming together virtually, in person and whatnot. You learn all kinds of things. Nobody can be aware of everything. So this is great. Thank you. I was not aware of that. Thank you.
Okay, well, I learned a lot today. I hope other people out there learned a lot today. I want to thank Mark, our guest today, for coming and talking with us. I want to thank everyone out there who's watching and attending. You can connect with us through Instagram, Facebook. I guess I don't know, I guess Twitter doesn't exist anymore. LinkedIn, YouTube, Empower Innovation Network. That's where you should make sure you're also listed there too. That's the CEC's version of their attempt at a version of LinkedIn. And then on the World Wide Web. So thank you everyone for attending today. I'm going to shut everything down and hopefully let's build a clean energy future.
Thank
All right.
you.
Bye, everyone.